in an obscure corner of an unexceptional galaxy, which is just one of 100 billion galaxies in the universe. And if you think that sounds depressing, consider this. There is no guarantee that our boring little rocky planet will be around forever. If we don't destroy it, maybe a stray asteroid will. And so where does that leave us? Astronomer Carl Sagan might say it brings us back to our roots as explorers and may drive us to become interplanetary, even intergalactic wanderers. This hour, Carl Sagan joins me to talk about the future of astronomy, space exploration, and the human race. And if you'd like to talk with Dr. Sagan, please give me a call. My number is 1-800-989-8255, 1-800-989-8255. And for our international listeners, you know what to do. Dial those international access codes, and then here in New York, 212-267-9621, 212-267-9621. And if you have access to America Online or CompuServe, you can join a live discussion about the program in those online services. Now let me welcome my guest. Dr. Carl Sagan is the David Duncan Professor of Astronomy and Space Science and the Director of the Laboratory of Planetary Studies at Cornell University in Ithaca, New York. He is co-founder and president of the Planetary Society and author of the new book, Pale Blue Dot, published by Random House, and it's my pleasure to welcome Dr. Sagan. Welcome to the program.
Thanks very much.
Pale Blue Dot. That's always the first question that every interviewer asks an author. Why the title?
Well, I was an experimenter on the Voyager 1 and 2 spacecraft, and after they swept by the Jupiter, Saturn, Uranus, and Neptune systems, it was possible to do something I had wanted to do from the beginning, and that is to turn the cameras on one of these spacecraft back to photograph the planet from which it had come. And clearly there would not be much scientific data from this because we were so far away that the Earth was just a point, a pale blue dot. But when we took the picture, there was something about it that seemed to me so poignant, vulnerable, tiny. And if we had photographed it from a much further distance, it would have been gone, lost against the backdrop of distant stars. And to me, I thought, that's us. That's our world. That's all of us. Everybody you know, everybody you love, everybody you ever heard of lived out their lives there on a mote of dust in a sunbeam. And it spoke to me about the need for us to care for one another and also to preserve the pale blue dot, which is the only home we've ever known. And it underscored the tininess, the comparative insignificance of our world and ourselves, as you said in your opening remarks.
Mm-hmm. You know, back when men were walking on the moon, there was that famous photo of the Earthrise over the moon and I guess you might call it the bright blue marble compared to your pale blue dot. That sort of led to movements like the environmental movement when people could see us as a united planet without the political boundaries.
Exactly.
Can we use the pale blue dot as an analogy to that or something that's even further looking?
That's it. It's a set of steps outward. And that Apollo 17 picture, I think, raised many people to an environmental consciousness. And the pale blue dot, at least for me, represents the last moment in spacecraft leaving the Earth in which you can see the Earth at all. And the idea that we are at the center of the universe, much less the reason that there is a universe, is strongly, powerfully counterindicated by the smallness of our world.
Whatever happened to the man in space program? I don't have to tell you how popular it was. It was the talk of the 60s. We all grew up with it. There was excitement. There was fervor. There was exploration. Everybody was behind it. A countless amount of money was going into it. Now it just lies fallow.
You're absolutely right. I think the first thing to say is that was a historic, a mythic achievement. And 1,000 years from now, when nobody will have any idea what GATT is or who the Speaker of the House was in the late 90s of the 20th century, people will remember Apollo because that was the time that humans first set foot on another world. But Apollo was not about science. It was not about exploration. Apollo was about the nuclear arms race. It was about intimidating other nations. It was about beat the Russians. And when we did beat the Russians, then the program was ended. And the clearest indication of that is the fact that the last astronaut to step on the moon was the first scientist. As soon as the scientists got there, the program was over. People said, why are we wasting our money on science? Now, lately, I mean, in the 70s and 80s and 90s, NASA has been very, for the manned program, the human program, I hate to use the word manned because there are women astronauts. In the human program, we're shuttle-oriented. What shuttle typically does is puts 5 or 6 or 7 people in a tin can 200 miles up in the air, and they launch a communication satellite or something that could just as well have been launched by an unmanned booster. And then the newts are doing fine, or the tomato plants didn't grow, or now with the next one, they're going to see how soft drinks taste in low Earth orbit, for heaven's sake. And then they come back down again and they say, oh, we've had another exploration. That's not exploration. That's like driving a bus over the same highway 200
That's Cola Wars in
miles.
space.
The Cola Wars. Whereas, if NASA had gone on to send humans to near-Earth asteroids or to land on Mars, the enthusiasm would have been maintained at a very high level. Now, I don't say that it's NASA's fault. NASA cannot make that decision on its own. It has to be made at a much higher level. But that decision was not made. NASA was left to its own devices. And that's why we have a falling off of interest in the space program for excellent reasons. People aren't stupid. They understand we're not going anywhere. Now, on the question that you raised at the very top of the show about isn't this terribly expensive and don't we have other enormously pressing needs? Of course we have other pressing needs, and that does take money. But look how the arithmetic works out. If we're not in a hurry, if we're talking about a few decades, and if the United States were to join with the other spacefaring nations on the planet, this could readily be done without any increase in the existing budgets. If we focused on the proper objectives, we could do this without breaking any banks at all.
You point out an interesting point that most people think that the NASA space budget is as big as our defense budget is, when it's in fact only 5%.
Yeah, exactly.
And I think that's true. People think, oh, we're spending all this money in space, when you look at the budget, we're really hardly spending anything.
It's true, and by just parenthetically, when we think of all those pressing social and environmental and other needs, and we wonder where to get the money from, the Department of Defense, spending, including hidden costs, over $300 billion a year in a post-Cold War era, is a very good place to take a close and hard look.
Mm-hmm. And another interesting point is that you mentioned in your book as far back, or as close, I guess I should say, as July of 1989, President Bush, on the 20th anniversary of the Apollo 11 landing on the moon, announced a long-term, and I'm reading from the page in your book, a long-term direction for the U.S. space program called the Space Exploration Initiative. It proposed a sequence of goals including a space station, a return of humans to the moon, and the first landing of humans on Mars. And in a later statement, Mr. Bush set 2019 as the target date. Do you know anybody who talks about this program anymore?
No.
Whatever happened to it?
What happened to it is it died in the process of being born because the Republican administration was not willing to commit any political capital to get it done. It's very easy to say we'll do something by 2019. That's whatever it is, 3.5 presidencies in the future. And who knows who'll be president then? You can't commit your successors. The thing about President Kennedy's Apollo program was that he made his historic speech in 1961, which said that we would use rocket boosters not yet conceived, alloys not yet invented, rendezvous and docking techniques not even conceived, to go to a moon that no one had ever been to, and we would do this by the end of the decade, And this was announced at a time when no American had even achieved Earth orbit. But the time scale was politically within reach. And the amazing thing is that we did it on that time scale. It is truly an extraordinary technological and human achievement.
And you make a case for colonizing space different than most people do in this book, and it's an excellent book. I think it's one of my own personal opinion is one of the best books you've put out recently. Just really very interesting to read, and it's chock full of stuff that I think most people don't realize about space and exploration. And your tact in this book is that you argue let's not go out in space for things you could argue for, science, exploration, education. You argue that we have to colonize space because that's the only way we might survive in the future.
That's right. I'm a big fan of robotic space exploration. I have been involved with it for 35 years. If you want to do science, that's the way to go. It's cheaper, it doesn't risk lives, you can go to more dangerous places, and so on. But as with Apollo, the only justifications that will work in the real world for human spaceflight are ones that involve some much broader political or historical agenda. And I believe there are three. One is emotional, and a lot of people feel it. I know a lot of people don't. And that is we come from wanderers, from hunter-gatherers. 99.9% of our tenure on Earth was in that condition, no fixed abode. It was long before we had villages and cities. And now the Earth is all explored. We're in some sedentary hiatus. And I think a lot of people long for some exploration. You don't have to do it yourself because of virtual reality. A few people exploring can communicate it to many. On the other hand, if your child is hungry, the appeal of this argument is not very high.
Yet when, parenthetically, when Comet Shoemaker-Levy 9 smashed into Jupiter, it was front-page news.
Yes,
people were transfixed by this.
And that brings me to of course, absolutely. And that brings me to the second and third points, which are much more immediate and practical. While I do not for a moment suggest that the Earth is a disposable planet, and I think we have to make the most heroic efforts to preserve the environment, it is a fact that our technology has reached formidable, maybe even awesome proportions. The environment that sustains us is very vulnerable. The thickness of the atmosphere that we breathe is, compared to the size of the Earth, about the thickness of the coat of shellac on a schoolroom globe. And that being the case, there is a chance that we will do ourselves in. We're certainly a danger to ourselves. I would like to see self-sustaining human communities on other worlds in the long run. It's no big hurry, so that we hedge our bets or diversify our portfolio. Clearly, our chances are much greater if we do that. And the third point is there is a specific danger that we are now able to identify, and that's connected with what you just said about Shoemaker-Levy 9 slamming into Jupiter last July. The Earth lives in a bad neighborhood in space. We orbit the sun amid a swarm, an enormous number of asteroids and comets. And you just take one look at the distribution of these orbits, and it's clear that the Earth has to run into them or they into us. Most of them are little, burn up in the atmosphere, don't do much harm. But the longer you wait, the more likely it is that a big one will hit. The ones that hit Jupiter last July, the biggest ones there, were about 1 kilometer across. They produced a blotch in the clouds of Jupiter that was about Earth-sized. And 1 kilometer across object is the size which would cause enormous environmental damage to the Earth. A 10-kilometer object that hit the Earth 65 million years ago wiped out the dinosaurs and 75% of the species of life on Earth. Now, to deal with this, first of all, we have to inventory these near-Earth objects. Surely we should be busy finding out if there's any danger from any particular object. We're not even doing that yet. And secondly, we ought to develop the technique to deal with an errant asteroid or comet if it's found to be on Earth impact trajectory. And without going into, we can if you want, the techniques for doing that, There's no way to do that unless we're out there. So this is, I claim, a very practical reason why in the long term humans have to be out in the inner solar system at least.
Scope out for us briefly, in a nutshell, what sequence of events would you foresee for us to go out and colonize? And where would we start? Where would be a good spot to look to live?
Well, I think there's a set of steps, the first of which is better scientific exploration of other worlds so we know the lay of the land, and the development of the technology for safe survival of humans in space for long periods of time. That ought to be the principal focus of the International Space Station that the Project United States is leading. It's not quite. I think it will probably be, but it isn't yet. And there's a few connected things with that. You would like to test out our ability to hide from solar flares, energetic events from the sun. You don't want to fry your astronauts. It happens not all that often. And then eventually there's a set of objects which are accessible, near-Earth asteroids, the very culprits we are worried about. Some of them are much easier to get to even than the moon, and much easier to get back from than the moon. Some of them are really strange looking, as if it's two worlds glued together, suggesting that we have here in microcosm, or stopped motion, part of the process that led to the origin of planets. We might be able to learn about our own origins there. And because of the low gravity, we can do all sorts of engineering work there and so on. But the real test, the real focus ought to be Mars, the nearest Earth-like planet. It has an atmosphere, polar caps, winds, 2 moons of its own, enormous volcanoes, but most important, it has clear evidence that 4 billion years ago it was a warm and wet world, unlike today. 4 billion years ago is also the time that life arose on Earth. And is it possible that 2 very similar nearby worlds, life arises on one and not the other? Or did life arise on Mars 4 billion years ago? Might it be, despite the negative Viking results, hanging on in some refugia subsurface, some oases? Or maybe it became extinct and the fossils, chemical and morphological, are waiting for the explorers from Earth. Mars is a very exciting place, and I would say those are the obvious objectives.
1-800-989-8255 is our number here. Why don't we go to the phones to Robert in Virginia Beach. Hi, Robert.
Hey.
Hey.
How are you?
Fine. How are you?
I'm great. Dr. Sagan, let me first say it's an honor to speak with you today.
Thank you.
You're welcome. I have a question. I guess you've answered it in part, but I'll fire it anyway. Seems to me that, as you mentioned, we're doing a lot of things to the environment that may be not irrevocable, but would have an unsatisfying result for us. They always say that nature, changes things and compensates, but we may not like what it does.
Mm-hmm.
So I'm wondering, with respect to colonization, where would we go? Where are the likely places we would go? What's the timetable to get there? And what are the basic steps for us to take before we can get there?
Well, I sort of answered all that in just a few minutes before you called.
Let me take it a step further.
Sure.
And say, let's say we were to go to Mars. Let's say we do the intermediary steps and go to Mars. Do we have to? Are we going to, as they show in science fiction movies, try to change the atmosphere of Mars and create giant colonies? Or are we going to live in shelters there?
Well, you see, the time scale I'm talking about is not the next few years. We would start in the next few decades, and we would really get going in the next few centuries. That's the appropriate time scale for the technology. So first there would be the first human landing on Mars, an international crew very likely, carrying environments in spacesuits and returning to the spaceship overnight. That would be followed by rudimentary habitats, closed ecological systems, in which you could live inside a bubble, maybe something like Biosphere 2 in Arizona. You would grow into a set of these. You can think of them as villages. But the long term, the grand possibility, and we don't know if it's possible, is to convert the environment, the surface environment of Mars, into something much more benign, much more Earth-like, something that science fiction writers have called terraforming,
right.
Transforming into something like the Earth. And while this is extremely difficult to do for, let's say, Venus, it doesn't look all that impossible for Mars, at least part of the way. The key point is that Mars is too cold, and the atmosphere doesn't have an ozone layer, so deadly ultraviolet light from the sun is striking the surface. Both of those mean put more atmosphere into Mars. And because it's cold, there's a lot of gases frozen away in the soil, chemically bound to the soil, or there is permafrost, the polar caps. And there might very well be ways to release the frozen and chemically bound gases already on the surface of Mars into the atmosphere, warm the place up, and shield the surface from the ultraviolet light. We don't know that. We obviously have to do some more work there. By the way, one key thing about going to Mars, which looks as if we can pull it off, it'll be much cheaper than otherwise, is to use Martian resources to generate fuel and oxidizer for the return journey. If you don't have to take your fuel and oxidizer to get back, if you only have to have enough to get to Mars and then there generate the stuff to get back, the weight you have to carry to Mars is much less, and the cost of the mission is much less.
How would you do that? Take it out of the soil?
One most interesting possibility, due to Robert Zubrin of Martin Marietta in Denver, is you carry compressed methane. Mm-hmm. You combine it with the carbon dioxide from the atmosphere. You generate molecular oxygen and combine it with the methane. You generate the molecular oxygen from the CO2. And now you have your fuel and oxidizer. And for long-term human stays on Mars, the molecular oxygen is used for breathing. Mm-hmm. The water is used for drinking and bathing. And as much as you can use the local resources, there's an enormous multiplier factor in how much you save in getting there. There are a set of clever ideas that have not at all been exploited, and it might turn out to be much less grand in terms of fiscal drain and activity than people have imagined.
Dr. Sagan, any new TV stuff or movie stuff? I understand you're working on a film. Is that correct?
Yes. I wrote a novel in the middle 80s called Contact, about the first receipt of a radio message from an advanced civilization in the depths of space. And now Warner Brothers is making it into a major feature film, as they say. My wife Ann Drian and I are co-producing and co-writing. George Miller, the Australian director, is directing, and Jodie Foster will be the lead.
Big name.
Yeah. Whoa. Just delighted. So summer of '96, if all goes well, it should be released.
Well, since you're helping and producing the film, I guess it would be true to the text, and a lot of movies do not go along with the book version. Can we expect that to happen here?
I would say it's a little too early to be sure. For one thing, the movies have a different idiom and requirement than books, and especially than novels. I could spend a lot of time in a novel telling what's inside the head of a character. In the movie, you got to show it. Yeah. It's a very interesting discipline, the difference between writing books and writing movies, and we've been greatly helped by Linda Opes, the executive producer, and George Miller in learning this. But so far, at least, it is true to the book, although changes to make it a filmic idiom. Right. So that it really works in cinema, of course, are being made. Whatever
happened to the SETI project, the search for extraterrestrial intelligence? Is that moot, dead, defunct? Is it? Well,
it's very interesting. Let me spend just a couple of minutes on that. There are a number of SETI projects. You use large radio telescopes to see if anyone is sending an intelligible message. Let me say a few words about one such study called Project Meta, and then I'll go on to the NASA one, which I suspect is what you're talking about. Mm-hmm. Meta is a program sponsored by a private membership organization, $5 and $10 contributions of members, nonprofit organization called the Planetary Society, which you mentioned at the top of the show that I'm president of. After 5 years of study and 2 years of follow-up, Paul Horowitz, who's the project director, he's a physics professor at Harvard, and I published a paper last year in the Astrophysical Journal. And what we found is this: to discriminate a genuine extraterrestrial intelligence signals from other sources of radio waves in space and from a huge radio frequency interference problem down here on Earth, we used a set of discriminants or filters. Narrowband transmission. It has to not rotate with the Earth. It has to be stronger than the occasional statistical noise that all electronic systems have, and so on. After we did that, we found there was a handful of events that passed through all the filters, and the 5 strongest of them, the 5 most intense putative signals, all came from the plane of the Milky Way galaxy. Now that's where the stars are, and you would not expect that a glitch in the electronics would only go on when you're looking at the plane of the Milky Way. And so, that's enough to make the heart start palpitating a little bit, mm-hmm. and goosebumps break out. But there's something extremely odd about it, and other search programs have found the same thing. When you go back and look at these places, 2 minutes later, it's not there. A day later, a month later, 7 years later, and we've done all that, we never see it again. And in science, a non-reproducible result is almost worthless. You have to be able to go back and check and have other observers who are skeptical or make different assumptions than you check it out. So we don't know what that is. Certainly those places in the sky deserve further examination. And we are moving on to a much bigger project called Beta, Billion-Channel Extraterrestrial Assay, which Paul Horowitz has almost ready. Now, at the same time, a still more sophisticated program was supported by NASA. It went on the air in October 1992, funded by Congress, and was ignominiously turned off by Congress just 1 year later. The argument presented by Senator Bryan of Nevada was that we didn't really know that there could be extraterrestrial life out there, and also it was too expensive. Well, of course we don't know whether there could be. The whole point is to find out. If we knew beforehand, we wouldn't have to look. And the consequences of success are enormous. I mean, they're transforming. It's hard to think of a more important discovery. And as far as cost goes, the NASA SETI program was costing about one attack helicopter a year. Now, there's a very nice coda to this story, and that is that while NASA is not supporting it, a number of captains of the electronics industry have made contributions totaling something around $7 million, so that the project is going to go back on the air in Australia sometime early next year, and that's something really great. The search program is so important, and the technology is now sufficiently inexpensive that this can go on even without government support, but it sure would be great if the government would change its mind on this.
1-800-989-8255 is our number. John in Elsa, Illinois. Hi, John.
Hi. Ira.
Yes.
Dr. Sagan, it's good to have the chance to talk to you.
Thank you.
Dr. Sagan, this is a little bit off the subject, but earlier in the show you were talking about the environment that sustains us on the planet, and our technology is advancing to the point that we can become a danger to ourselves.
Mm-hmm.
There's been a discussion that I've heard raised a few times in the last couple of years about a solar energy collection system that would either be in an orbit of some sort, maybe a geosynchronous, or mounted on the moon, and would beam
I think by microwave energy's
That's right.
power back to the planet.
Yeah.
Seems to me that this possibly could be creating an effective increase in the size of the disk that Earth presents to the sun, and as such, couldn't that be raising the net energy collection by the planet, creating some sort of a second cousin to global warming?
I don't quite see how that would work, but I don't use that argument in my book Pale Blue Dot. Why not? Because if you have a means of converting sunlight into electricity, why put it in Earth orbit? The arguments are, okay, well, you can put it high up enough so that you're always looking at the sun. That's just a factor of 2. The expense of putting it up into Earth orbit is much, and then beaming the energy down with microwaves, is much more than a factor of 2. This scheme, which was looked at by the Congressional Research Office and by the National Academy of Sciences, does not seem to be cost effective. However, the general question you raise, if global warming is produced mainly by greenhouse gases, the burning of fossil fuels, coal, oil, natural gas, wood, can we find some alternative energy sources? The answer is absolutely. We can do the conversion of sunlight into electricity on the ground. We can use wind turbines. We can use biomass conversion. We can use hydrogen fuel cells. And with any serious development of that technology, we can gradually displace the fossil fuel economy. And before then, we can use the fossil fuel economy much more efficiently. Why are we content with cars that go 25 miles a gallon when it's perfectly possible to have cars that go 75 miles a gallon with adequate acceleration and looking spiffy and safe? It's perfectly possible to do. There are many things we can do with down-here technology to make our environment a lot safer.
All right, let's go to Sean in Kansas City. Mo, hi, Sean.
Hi.
Hi.
I just had a comment, and I'll take the comment off the air. What I wanted to ask Dr. Sagan was, it seems to me that the way to increase space exploration is to show commercial industry that it would be profitable to do so. Because I think as soon as you show business that there's money to be made in space, you'll have to fight to keep them on the ground. And I just wanted his comments on that.
Okay, thank you.
Thanks. I think you're absolutely right. If there was money to be made, you'd have to fight to keep them off.
You mentioned one of the reasons you might go into space is that there might be diamonds.
Wait. Let me before we get to that, which is essentially a science fiction theme. Why is it that industry is not elbowing each other to get into space? And the reason is that there is no commercially viable project that anyone has come up with, except, of course, for the aerospace manufacturers who have something to do by building the means to get up there. Mm. But no crystals, no pharmaceuticals, no ball bearings, no alloys of immiscible metals, nothing like that. The criterion ought to be this. To make your technology in space is going to cost X dollars. Can you produce a cheaper or better alternative product down on Earth for X dollars? And the answer always seems to be yes. When the answer is no, then we'll have industrialization. But it's possible the answer will never be that it's cheaper to do it up there. Now, there are some exotic possibilities, and Ira just mentioned one, which is there is a single paper in the Japanese scientific literature suggesting that diamonds might be naturally made on Mars more readily than on Earth. And, okay, so maybe...
Now we've got your attention.
In that case, we can have General Electric and De Beers finance the space program, but you can't be sure of that. In any case, we have to go to Mars to find out.
Yeah, but to come full circle on this, so you're making the argument that the reason we have to go into space is not for commercial reasons, but for solely practical survival reasons, that the odds are better. And you said it, and I can't remember where, the odds are better of a asteroid or comet smashing into our planet and destroying us or dying in such a collision than they are from dying in an airplane crash.
It's like this. As far as we can tell from the present statistics of near Earth asteroids, we can ask, what is the chance that the Earth will be hit in the next century by an asteroid or comet that will destroy the global civilization? I mean, that's the right question. And the present answer is 1 chance in 2,000. Now, you can decide whether that's a large number or a small number, but by comparison, the chance of dying in a single randomly selected commercial scheduled airline flight is 1 in 2 million. And now a lot of people worry, especially these days, about flying in airplanes, and they take out insurance policies. All I'm saying is, here also, with the odds 1,000 times higher, we should take out insurance policies.
Mm-hmm. Let's take out a policy. Michael, hi, age 10. Michael, hi, how are you?
Fine. My question is now, if you could get to the center of the galaxy, the Milky Way, what would it look like? Could you colonize it, and how would you get there? By what type of ship? What type of engine?
Really good questions, Michael. I'm so glad at age 10 you're that far along. By age 20, I hope you will be making significant contributions to the subject. The center of the galaxy is about 25,000 light years away. If we could travel almost at the speed of light, we can't travel at the speed of light, but if we could travel almost at the speed of light, then on board the ship, it could take us very brief periods of time to get there. But as measured from the Earth, it would be 25,000 years for us to get there. So if you went there and fiddled around a little bit and came back, it would be 50,000 years later and all your friends would be gone. So that is a requirement imposed on us by special relativity. It's a law of nature, and it looks very hard to get around that, except for an enormously advanced civilization, much more powers than we have. And I talk about that in that novel Contact we were talking about before. What it would look like, well, you see, it's really, we live out in the boondocks of the galaxy, and it's dark because the stars are so far apart. At the center of the galaxy, the stars are much closer together, and it is gorgeous, multicolored stars. I wouldn't say touching, but very much closer together than they are here. The idea of making human communities at the center of the galaxy may be, but that's a dangerous place, the center of the galaxy. It blows up every now and then, and it looks as if there's a giant black hole at the center of the galaxy. I think we ought to stay for a while out here in our remote spiral arm where things are a lot safer.
Okay, Michael?
Okay.
You want to be an astronaut or an astronomer when you grow up?
Scientific engineer.
Scientific engineer. Okay. Good luck to you.
Bye.
Thanks for calling. Bye.
That was great.
We got a lot of young callers on
wonderful.
Science Friday, and we're very happy to invite them to call. I guess sometimes they're home early on Friday from school or wherever. I don't care if they're playing hooky, listening to our program. That's just fine. One of the most interesting parts of the book, and you have it right at the beginning toward the front, is most of us, when we think about where would we like to find the origins of life in our solar system, that would be similar to the way it evolved on Earth. We'd say, let's go to one of the planets, go to Mars, go to Venus. But you, because you have studied this for a long time, say, let's go to a moon of Saturn called Titan. That's where we may find those primordial building blocks of life. Why Titan? What's going on there?
Yeah, it's such a great finding, and it's so unexpected. Who would have figured? Well, just as you say, you would have figured Mars or nearby.
Right.
Titan is the big moon of Saturn, and it's covered with an orange haze layer and clouds. That's really weird for a moon to have clouds and an atmosphere. Not just that. The atmospheric pressure is the closest of any world in the solar system to what it is here. And the atmosphere is made mainly of nitrogen, N2, just as the atmosphere of the Earth is. Now, what is that orange stuff? We know now quite reliably, I think we can really be almost confident about it, that it is complex organic matter, including, if you drop it in water, the amino acids, the building blocks of proteins, and the nucleotide bases, the building blocks of the nucleic acids, the very stuff of life here on Earth, and it's dropping from the skies like manna from heaven.
But it's cold. It's
onto
not
the surface.
It's not like
absolutely right. So the some of the building blocks, key building blocks, are being made and are being preserved, you would think, because of the very low temperatures. So they don't decay. They're waiting for us. Let's go find them. But it's even better than that. The Saturn system is, of course, much further from the sun, 10 times further from the sun than the Earth is, so it has to be very cold. It's 94 Kelvin or something like that on average at the surface of Titan. And so you would say, look, this is the place where it misses out, being an analogy with the Earth, because we have liquid water here that's essential for life. They don't have it there. But we know that the solid surface of Titan contains ice. And when a comet slams into Titan, it produces a temporary pool and slurry of liquid water. So now we can ask, over the whole history of Titan, and for an average place on the surface, how long did it see liquid water? And the answer seems to be something like 1,000 years. 1,000 years in which the organics that fell from the sky are mixed in with liquid water at reasonable temperatures. Is that enough to make a significant further step towards the origin of life? We don't know. But Titan is sitting there waiting for us, and we're going. Because in 3 years, a joint NASA-ESA, European Space Agency, mission called Cassini is to be launched to arrive in the Saturn system in the year 2004, and an entry probe capable of examining organic chemistry is going to enter into the atmosphere of Titan, sampling as it descends, and if we're lucky, it will survive the landing and see what's down there. It's a very interesting fact that if you want to understand about the origin of life on Earth, the best place to go may be Titan.
Amazing. I'm talking with Carl Sagan this hour on Talk of the Nation from National Public Radio. And, of course, a lot of this came out of the Voyager, mostly all of it. The modern stuff that we know came out of the Voyager missions.
Quite right. And the Titan stuff I've just been describing is fundamentally based on Voyager data. You see, there's a spacecraft, 2 spacecraft, Voyager 1 and 2, product of American industry, run by the government via the Jet Propulsion Laboratory of NASA and Caltech, that came in on time, under budget, and vastly exceeded the expectations of its designers. It is responsible for almost all we know about most of the solar system, the Jupiter, Saturn, Uranus, and Neptune systems, and now those 2 spacecraft, still working splendidly, are on their way to the stars.
Looking back at that pale blue dot. Let's go to Jane in Eugene, Oregon. Hi, Jane.
Hi. Thanks for taking my call.
You're welcome.
I'm wondering, Mr. Sagan, if you are assuming that we will not trash any new environment that we may create out in space, and if so, what do you base this assumption on?
This wildly optimistic assumption. Of course, we are a lot more slovenly than we ought to be. And we are not doing well with our own planet.
Right.
And you might very well argue, let's hold off messing up other worlds until we can demonstrate we know what to do with our own. Let's make the Earth an Earth-like planet before we talk about making other worlds an Earth-like planet. I would be very concerned along these lines if there were life on some other planet. Then I would say that planet belongs, whatever the word belong means, to the beings on that planet, and we have a real responsibility to exercise the most extreme care there. But as far as we know, there is no life in the entire solar system except on the 3rd planet from the sun, the Earth.
Is our society ready for news about life on another planet? If we were to conclusively say we have discovered life someplace else. Can we handle that?
If it's microbial, I think nobody is going to worry about it at all. But if we get a message from another civilization in the depths of space, that's very different. And I try to imagine what the various reactions of various human constituencies will be in my novel contact, I think many people would look at it with an enormous sense of wonder. Yeah. You see, if we got a message, it would have to be from somebody much smarter than us, because anybody dumber than us is too dumb to send a message. We've just invented radio. So really smart guys telling us what they know. That means that every branch of human knowledge is now up for reconsideration. Some people, of course, and not just human knowledge, but things like social organization and religion. Some people, of course, will be defensive about it and will worry, what have they assumed that isn't true? And even in science, do we get something wrong in fundamental astronomy? Do we make a mistake in mathematics somewhere? You can see people being really nervous, but the chance to tap in to such knowledge, it's like going to school for the first time.
I'm running out of time. I have just 2 minutes left, but while I have you here, I have to ask you a couple of science questions.
Please.
One, what is your take on the problem that we've just been listening about, that the news that the universe may be younger than some of the galaxies?
It's fantastic, isn't it? It's like someone telling you that their children are older than they are. Something is wrong. But we're just talking about factors of two. Either our method of dating the stars is wrong, or our method of dating the universe is wrong. Those are the only two possibilities. I think the most likely case is that we have the age of the stars right, and we'll find out that there's something wrong with our dating of the universe. But tune in; it's a great question.
Yeah. And the other great question is, what is all the missing dark matter? Do we have any idea? It gets worse all the time. The more we keep hearing more about it.
Well, there are plenty of ideas, then all mutually exclusive. It's dark matter is just stuff that we know it's there from its gravitational influence, but we can't see. Yeah. Well, you, Ira, and I are sources of matter that don't radiate much into space, and yet we have some mass. It might be, snowballs. It might be neutrinos with rest mass. It might be black holes. It might be a kind of elementary particle that no one on Earth has detected yet. We don't know. It ranges from the prosaic to the extremely exotic. And there, too, we're going to find out the answer.
It's very sobering that we could be sitting in objects that 95% of the universe is made of, and we have no idea what it is. That is really a sobering thought.
In that way, it's depressing. But the other way is, look, we've discovered that they're there, and now let's find out what it is, and we are on an upward trajectory towards learning, and hats off to science for figuring that out.
Well, thank you very much for joining me today. It's been a pleasure having you today. Dr. Carl Sagan is professor of astronomy and space sciences at Cornell University in Ithaca, New York, and author of the new book Pale Blue Dot, published by Random House, and I highly recommend it. Thanks for listening. Remember to visit ScienceFriday.com for more information on this topic and every topic we talk about on Science Friday. See you next time. I'm Ira Flato.